Differentiation of a product. Product rule. In differentiation, if the expression is such that it cannot be easily multiplied or divided into separate terms, the product rule or the quotient rule are used. To talk about the product rule, we want to look at two scenarios, and one of them is if y is equal to AU, where A is a constant, is A, right? A is a constant, and U is a function. It's a function of x. Then, according to the product rule, dy dx is gonna be A du dx, right? So for the first rule, since u is a function of x, the dy dx and a is a constant, you're gonna differentiate u with respect to x and we multiply by a constant, right? Now let's look at the second scenario 2. If y is equal to uv, where u and v are both, let me bring it down a bit, are both functions of x, then according to the product rule, dy dx is gonna be the derivative of u multiplied by v, so it's gonna be v du dx, then plus derivative of v times u, so it's gonna be u dv dx, right? So let us take some trials to appreciate the concept. Let's say 1, given that y is equal to 4x raised to the power 5, find dy dx. Okay, right, so to look for the first derivative of y is equal to 4 x raised to the power 5 using the product rule solution, what we need to first do is some declaration. So we're going to say let IU comparing y is equal to 4 x raised to the power 5 to y is equal to AU. You know, A is a constant and U is the function which is of x, right? A function of x. Then over here, our A is the 4, which is a constant, and U is going to be the function of x, right? So we're going to say let U be equal to x raised to the power 5, and 4 is our constant as we have over here, right? So A is our 4 and our U is what? X raised to the power 5. And according to the product rule of this function, y is equal to A U, where U is the function of x and A is a constant, the only thing we're going to do is just to find the derivative of U with respect to x, then we multiply by the constant, right? So coming to this one, what we're going to do is to find the derivative of U with respect to x, and then we've already looked at how to do that. in our previous videos. If you have challenge in search, please try to visit the previous videos. So to differentiate u with respect to x, we're just going to multiply the whole of this term by 5. Then we have our x, and we decrease the exponent by 1, which is going to give us what? 4, right? Now we're going to multiply our dx dy dx is going to give us a du dx, right? So this implies that our dy dx is going to be, what's my a? Comparing, there's our a is what? Our a is 4, okay, and then our du dx is what we had here, okay. We differentiated the u with respect to x, and we had 5x raised to the power of 4, so we're gonna have 5x raised to the power of 4, and actually 4 is gonna multiply by 5, and 4 5 is gonna give us 20, and then x raised to the power of 4. Okay, so easily that is how to find the dy dx of y is equal to 4x raised to the power of 5. Let us take an example to also look at the second scenario. Okay, so for the second scenario, let's look at this example. If, that's example 2, right? If y is equal to x minus 3 then x squared plus 1, find dy dx. Okay, so solution. Right, so this one really depicts our second scenario, which says that we having y is equal to uv, whereby we have u and v being both functions of x, right? And then look at how it is done. Dy dx is going to be dv v du dx plus u dv dx, right? So we're going to imitate the second scenario over here. We have we can say, let us first do some declarations. Let u be equal to x minus 3 and v be equal to x squared plus 1, right? X squared plus 1. Right, so you realize that if we have this, then our y is in a form of uv. Do you see that? Yeah, instead of, in place of x minus 3, we have u, which is equal to x minus 3, and in place of x squared plus 1, we have v, right? So this one is currently in our format, and given y is equal to uv, the product rule says that dy dx should be equal to v du dx plus u dv dx, right? So given this, we already have our u and our v, then we need to find the du dx and dv dx, right? So du dx, from here we saw that u, this one looks like v, right? u is equal to x minus 3. So to differentiate u with respect to x, you're just going to get 1. You can all see that, right? Please, if you have challenge doing this differentiation, watch the previous video to get a better understanding, right? Before you come back to this one. And then the x2 is going to give us what? V is x squared plus 1, so that's going to give us 2. You multiply 2 by x. We're separating we're doing a differentiation term by term, right? So we're taking the x squared first, and then multiply the 2 by x. So we're going to get 2x, and then we decrease the exponent by 1, and 2 minus 1 is going to give us 1. If we differentiate a constant, we're going to get 0. So that is why I'm not writing anything. The du dx, I wrote just 1 because over at the u, the exponent of this x is 1. So if I multiply 1 by the s, and then I decrease the exponent by 1, is going to be 1 minus 1. That will give me 0. And x raised to the power 0 is 1. And I'll get 1 times 1 giving me 1. Okay. Now, the minus 3, if I differentiate it, it is a constant, it's going to give me 0. So 0 is insignificant. That is why I'm not writing anything here. The 2x2, you realize that when you differentiate a 1, you're going to get a 0. And 0 is what? Insignificant. That is why I'm not writing it. Right? So upon writing this, the next step is you're just going to do some sort of substitutions. Wherever you see v, you put x squared plus 1 there, and whatever you see, you substitute x minus 3 there. In place of the u dx, you have 1. In place of the v dx, you have what? 2x, right? So let us do that substitution, and afterwards probably some simplification. dy dx is going to give us v, and our v is what? x squared plus 1. So we have x squared plus 1 times 1 times du dx, which is 1. u dx is 1. Then plus v plus u, right? And u is what? U is x minus 3. So x minus 3 times what? dv dx. And dv dx gave us 2x, so we're going to have 2x here, right? So currently we're going to have dy dx is going to be, you multiply this 1 through what is inside the bracket, and 1 times x squared is going to give us x squared, plus 1 times 1 will give us what? 1. Then we're going to the second term. You could multiply the 2x through all the terms in the bracket. Multiplying 2x by x is going to give us 2x squared, and then also multiplying 2x by minus 3 is going to give us 2 3 is what? 6x, right? 6x. And we can do some simplification. So we're going to have, bring it down a bit, going to have dy dx, and will be, you can see grouping of like terms of x squared plus what? 2x squared minus 6x plus what? 1. Then dy dx will be x squared plus 2x squared is going to give us 3x squared. Then minus 6x plus 1. And simply we have differentiated y is equal to x minus 3 x squared plus 1 easily using the product rule. If you find this video interesting, subscribe to the channel for more research. See you when I see you. Bye.